Ivano, just for information, for Ivano, Ivano, this was a mistake from my side because this was the link for the speaker. So you are with the speaker, but you have not to speak.
Okay, it's nice for me.
Hello, Ivano.
I did some confusion because the link, Ivano, the link that I received was the link for the speaker, and the attendees have to use the YouTube, but it's not a problem because you can stay here. But different from all the other side, you're a listener today.
I promise to all that I will be silent. Absolutely.
Oh, we can turn off microphone. So it's and also we got an email today from our client that saying that we increased the size of the room. It has been increased to 100 people, so we could actually have this this thing here. Well, more or less.
No, let's say so. Basically, I think that everybody's
Good morning to everyone. Is it okay? Is it working now? It takes a few seconds.
Yes, we can hear you.
Okay. I mean in the YouTube channel, because I'm not sure. I see a picture of the Odorprep there. Anyway, I think we are starting now. So good morning to everyone. Welcome to this initiative that has started now with this new situation that we have now, and it has many advantages at this stage, and disadvantages as well. And one of the advantages is that we are able to do a webinar online. Probably you have got a few webinars during this period of coronavirus, and this time we have gathered a nice group of people that from different countries around, from Italy, from France, from Belgium, and they are going to speak about different initiatives and projects related to the odor management, and with a link in all these projects that is the Odorprep sampler. So yeah, good morning to everyone. Okay, so I see that I don't know if we can see the. I'm going to share my screen. Yep. So we have put the title "New Frontiers in Odor Control" for this webinar, and we have organized in the past a few events and conferences, but this is going to be the first time we organize a webinar online. And please excuse us if we make any mistake. We will try to make our best with this. So for this presentation, I'd like to comment a little bit the program. So we have first speaker and Claude Romain as first speaker. Then that she will speak about interest of automatic odor sampling devices, illustration with the Bologna study. Afterwards, Robert Kelly, Mr. Kelly, will speak about innovative photocatalytic cover for treatment of nuisance, Odorprep support. Later, Mr. Rossini, Cesare Rossini, will speak about the OdorNet, a project for monitoring olfactory phenomena in the municipality of Falconara Marittima. And our last speaker will be Federico Cangialosi, and he will speak about mechanical biological treatment plant, statistical evaluation of hydrogen sulfide and ammonia concentrations in ambient air, and criteria for automatic odor sampling. So each speaker will speak for 15 minutes, and then we will have a round table and that you can join. So there will be two ways for making questions if you want to make any question. First, it's our YouTube channel. So here we have our YouTube channel. So you can in this chat put your questions, and I will read them once I get them. But there is another way to if you want to make the questions yourself instead of me reading them, you can actually just click in a link. You just have to put this vba.s/meeting, and you access, and then you can just click on any share, and then you can make the question yourself. So there will be two ways. Once with the YouTube channel, you can put here, you can post your questions. And if you want to make your question yourself, you can join in this meeting room, and you are more than welcome to for any question or comment that you may want to do. So I think we are going to start now, and I would like to introduce you to Anne-Claude Romain. She studied chemistry and environmental sciences at the University of Liège in Belgium, and obtained a PhD on sensor arrays for environmental odor monitoring. Professor Romain is the head of the research group Sensing of Atmospheres and Monitoring in the University of Liège, SAM, in Arlon, Belgium, from 2014. Professor Romain is also a member of scientific technical committees as NOS, ISO-N, ORBI, IWA, and international and national boards, CIN, National Health Council, etc. So please, Anne-Claude, thank you very much for your presentation beforehand, and please go ahead, and you have 15 minutes. So
yeah, I will try to respect the time. So first I share my screen, just please. Okay, so Carlos, please tell me when you see my presentation.
Yes, everything is okay now.
Okay, perfect. So dear all, it's really a pleasure for me to present our experience with the Odorprep sampling system. Even if it's true, it would have been nicer to meet you face to face, but well, it's the life, this life. So at the end of 2018, we were contacted by Lab Service Analytica. Well, I shall probably not quote him, but as you know him, sure. So the famous Cesare tried to contact me, and he wanted to know if there were in Wallonia areas where odor troubles occurred. Well, also at this time there were not big issue with odor complaints in Wallonia. We were interested in testing the automatic sampling device, and we notified also the Scientific Institute of Public Service of Wallonia. So it is the Environmental Institute, official institute of Wallonia. So it is ICEP. And my collaborator from ICEP, so Sébastien Failly, was very interesting also in testing an automatic sampler, not only for odor measurement, but also for air pollutants absorption system and measurement. So, okay. So finally, we found two other case studies, and so ICEP and our lab were interested for developing new odor measurement methods for complex industrial area where there are a mixture of odor emissions. So, of course, the first scope was to evaluate the Odorprep automatic sampling system. Yes, it was the first scope, but it was also the occasion to involve citizens and local authorities in this project. But it did not work out the way we wanted to. I will explain later in my presentation, but very briefly. There were also, of course, scientific aims because we are scientists. And so we perform several data collection with usual tools like the one olfactometry, chemical analysis, questionnaire, and also ENOS, that we call now IOMS. And we had two research aims during this project. It's to try, it was a preliminary study. It's to check the link, to check the odor concentration that we could measure at the receptor level thanks to an automatic sample system, and to use the result, the concentration, odor concentration we obtain, and to use them to validate or even to apply reverse modeling approach and to validate odor dispersion. But it is really preliminary. And ISEP was also interested in finding maybe some key compounds more linked to other complaints, especially for this site in NG. So the first study was performed in NG. As you can see here, it's a valley. It's a, well, NG, it's a small town near Liège, and so you have here, if I'm not wrong, the Meuse, so a big river in behind this valley, and there is steep inclines, because it's a valley, of course. And so in this region, there are quite very frequently thermal inversion. What is also interesting in this valley for our purpose, for our study, is that there are quite several industries. There are chemical fertilizer factory, placer, industrial waste treatment, etc. And ISEP monitors since several years the quality of the air in this valley, because in general this air is very bad. And there are several other complaints as well. And so for the Odorprep sampling system, so the study lasts from 2018 to, well, November 2018, sorry, to August 2019. So it's about years ago now. The second case was Abbé. It's an area that our lab knows very well, because performing several measurements of odor since several years here as well. The study was shorter, only 3-4 months, but I will not focus too much on this case, because we don't have time in 50 minutes to present everything. So lab system analytica, lab service analytica, I'm sorry if I don't use the correct term. So, well, Cesare lent us 2 Odorprep samplers for about 1 year. ISEP installed 2 trailers equipped with a chemical analyzer to perform continuous measurement of chemical compounds. We perform olfactometric analysis. We use ADMS as an odor dispersion model software. And you install also our own IOMS. So IOMS is Instrumental Odor Monitoring System. So it is the new acronym for ENOS in the site of Abbé, but I will not focus too much today. And what is also important in their study, because there is the app on the mobile phone for trigger the automatic sampling, is to involve external people. So in this project, we involve 2 environmental officers of the municipality of Angers, and for Abbé, a technician of the site, because they have to trigger the sampling with their smartphone, and so they are in charge to do this. In addition to this, we give them a questionnaire to fill with a predefined frequency, and of course each time there is a triggering, and this questionnaire, among different things, they have to mention and to characterize the odor they smell, to be able maybe to identify the source, because as I explained you in NGs, there are different sources of odor and different kind of smell. So very fast, NG here, so you can see the Meuse and the underlying.
La grabación ha comenzado.
Sorry, I heard something strange.
Sorry, it's just that the recording. Just go ahead, Claude.
Okay. And so there is underlying shape here. So this is the different factories that you can have in NG. And so we decide, for different reasons that I can explain if you ask me a question later, to localize the sampler here. So really close one of the main odor factory here. So in the fence line, in the parking of this factory, and a little bit far So the distance is about 350 meters from the parking. It is close to a school, and the officer that have to trigger the automatic sampling are from about 1 kilometer, a little bit less from the automatic sampling system device. So Abea will have no time to explain this. So I go up. Sorry. So 3 pictures for illustration the localization. You have the school here, and we installed the Odorprep in the prairie of the school. And they are the big fertilizer factory is on the left side of the picture here, and the river, the Meuse, is in front of the school here. You see the trailer, you see my colleague, well, my collaborator, Sébastien Failly from ICEP, and the famous César here. And you can see that in the streets here, they are quite typical organization of worker dwelling, worker home here in the street. It is the parking of the fertilizer factory here, and again, trailer and the Odorprep system. So I would like to explain you more data and result we get in NGIS, but however the time is very short, so I will have no time today to enter in more detail. And for your information, however, I will explain them in more detail during the NOS 2021. So this is also the reason why I don't want to give too much detail on this result. But however, you can see that on the 2 locations in Angie, we get 6 triggering about 5 days during 8 months of study. So it's really low, and we are a little bit disappointed about these results, because usually there are more complaints, and we really wanted to get more data, but for our study. For the citizen, it's great, but for us, it's not so great. It was not so great. And you can check here the value, the concentration you get. So in the fence line, and a little bit farther, so at the receptor level here. We can discuss, but I will not do it, how we could use this kind of information to perform odor dispersion model, but I will not take too much time on this today. And so we have here the real-time measurement of, for instance, here ammonia, and we point out when there is a triggering, so an automatic sampling regarding the chemical concentration. The idea was to try to find a relation between the chemical concentration and the odor concentration we measure at the receptor level and at the fence line, but it was not so easy to find, as you can see. But as I mentioned, we don't have a lot of data in the same way, so it's not very representative probably. But however, it was not easy. But something that I can explain you, however, is that we observed that it was not possible to observe some things very interesting if we take the same times of the sampling, odor sampling time, and the chemical concentration measurement. So we have to add a delay, or retry a delay at about 2 hours in function of the wind direction, and also it is due probably the fact that the officer that activates the sampling are 1 kilometer far from the automatic sampler, and that even if the analyzer measures continuously chemical compounds, the time the odor has to reach the officer nose could take some delay in function of the wind's direction, but also the stability of the atmosphere. So there is something that we can discuss here. So the main scope of this Wallonia project was to evaluate Odorprep, and it is the title at the end of my talk here. So I would like to give you my first impression, but however, it was 2 years ago. So to be honest, I don't really try the Odorprep system since this first experience for different reasons. So maybe there are some aspects they change since that time. But however, so the good point of this automatic system, it is really a good approach to be able to collect odor at the receptor level. It's a good way, it's really a sampling that it is representative of the perception at the receptor level because it is activated, triggered by a mobile phone app, by a citizen, by an officer, by a company, I don't know. So it is really interesting for that point of view. And as you probably know, sampling at the receptor site is often challenging due to the low odor concentration, of course, that we have at the receptor, and even sometimes at the fence line. And as all of you knows as well, especially if you have already performed field inspection. I don't know if it's usual for you to perform field inspection, but in Belgium it's a way that you use frequently. The perception time of an odor is short. It's called by puff, as you know. So in that way, if the people that have to trigger the activation of the sampling is really representative of this, and we are able to catch a low odor concentration. It was a practical tool. However, if the installation is quite heavy and the device itself is heavy, but when it is installed, the maintenance is very, very small. And something very useful, at the opposite maybe of homemade or lab-made automatic system that we could have in some companies, is that there is a good control of the temperature and the sunlight protection as well. And thanks to the app, we can activate sampling even during the night and keep safe the bags during several hours before to collect it. And it is really simple. Yeah, I fast.
1 minute.
I don't know the time. Okay, thank you, Carlos, to prevent me. So it is easy to use, so it's remote sampling, the bag collecting and replacement is really easy to do. The interface of the app is very simple, even for citizens. It's also versatile, so you can add extra instruments with their own sampling line in the device, and it's really helpful from the point of view and the material use in the respect of our European standard for olfactometry. However, we had some proposal or some questions, that we can discuss, but again, maybe there is change now since 2 years. The trouble maybe could be linked to the electrical supply because we have also automatic sampling system, but with battery because it's quite light and we can move it very fast. But here we need, for temperature control, for instance, we need to have high voltage, and so it is important to notice this. And if you want to use, yes, you need to have access to electrical supply. The size of the sample bag could be a little bit higher, especially when we are working at the receptor level because the concentration are very low. When we test the Odorprep system, we only on our disposal nylofan materials, but as you know, for some compounds and especially for ammonia H2S is not a good one. So I guess that maybe they propose other kind of material. The flow adjustment, it will be great if you can be able ourselves to adjust the flow. And we propose maybe to couple this device with a cloud to have an idea of the localization, and maybe a webcam to be sure that there are not that maybe people they put a strong odor above the sampling line. Why not? You can imagine. So the main issue, we are asking the question at the end. Yeah, it's the last one. Don't be worried. Really. Is this Autosample could be considered equivalent at the end to a speed radar for odor? Because we were very surprised that there were no even a few complaints during the campaign. And it was not very great for us, but for the citizen is great. So maybe thanks to the shape, etc. I don't know. Maybe it can be a confusion with a radar for odor. It's a little bit a joke, but why not? Involvement of the citizen was not so nice that we would like to have, but I have no more time to in more detail because Carlos remember me that I don't respect my time as usual. I'm sorry. So I mentioned here the main interest because it was the title of my talk, and I expose here also the main interest, but I have no time. You can read it, whether you will have at your disposal my presentation, and so you can see here consideration regarding the interest of this system. Thank you very much, and sorry not respecting perfectly my time. And thank you to Sébastien. I know he's listening now, and my colleague Noémie, Cédric, David, Axel, and the people that were involved in the 2 case studies. Thank you.
Okay, thank you very much, Jean-Claude. Sorry for this. Just we have 15 minutes, and that's because otherwise I would be listening to you for really long time.
Yeah, no, thank you, guys. I know, it's my problem. It's really difficult to respect the time. Well, sorry.
Okay.
Thank you.
Okay, so our next speaker is Dr. Robert Kelly. Dr. Robert Kelly heads the international team of Suez, dedicated to solutions related to odors, located in Paris. Mr. Kelly studied microbiology at the University of Guelph, Canada. Mr. Kelly has a long experience in developing sustainable odor management strategies, including real-time monitoring of nuisance, odor emissions, and impact assessments. So please, Robert. Okay, I see that you are ready here.
Thank you, Carlos. You confirm that you can see my screen? Yes?
Yes.
Great. Well, thank you for the introduction, and thanks to everyone for joining in this morning. Today, I'd like to present to you one of our solutions within Suez, which we call ActiLayer. In fact, it's an innovative solution for the treatment of nuisance odors from diffuse sources via photocatalysis. And of course, the link to the previous presentation is how we integrated the use of the Odorprep automated sampling device within 2 reference projects that I'd like to share with you. So just to quickly get started, so you have an idea of who our team is, because Suez is a large organization. We're part of a division known as Smart Environmental Solutions, and in fact, we're the Air and Climate division. So if you look at our activities, they fall into 3 main categories. The first, which we'll focus on today, is really about nuisance odor impact and integrating industrial activities within the local environment. So we're really focused on odorant compounds, volatile organic compounds, H2S, reduced sulfur emissions. We also work more and more on urban air quality initiatives, and you'll see it's similar strategies, but on different types of pollutants, with a link more focused on public health initiatives. So we're talking about fine particulate matter or NO2 emissions. And then finally, the third category is on surveillance and mitigation of greenhouse gas emissions. So not really an air quality initiative per se, but more linked to climate change initiatives. But irregardless of which of these three areas we're working in, what's important to know is that we operate as a solutions integrator. It means we work with an ecosystem of partners such as Lab Services, Analytica. We're not only working with in-house solutions, we're trying to bring to our clients the best of technology that's available on the market. And we're present along the entire value chain. It means beginning with a diagnostic phase, typically to understand, really to characterize the nature of the problem, the type of pollution, the scale. Am I talking about a single source or an entire plant or an entire city? And then we move into treatment, remediation solutions. Once we've put in place a treatment system, we have an increasing interest in real-time performance monitoring. And finally, when we have these types of digital platforms, we're building up online databases. And so now we can have a big data type approach, try and optimize plant operations, for example. So we have this continuous improvement process. But really, irrespective of the project, our main focus, our commitment is to identify strategies to better integrate industrial activities, industrial infrastructure within an increasingly urban environment. I'm sure many people have noticed that infrastructure such as wastewater treatment plants, composting facilities, landfilling activities, or even industrial parks are really facing urban encroachment. It means we have residential neighborhoods coming up right up to the fence line of the facilities. And so we have to come up with innovative strategies to go beyond just a risk management and to really focus on environmental footprint and really having a more proactive approach in terms of quality of life for the local community. So with that, I'd like to focus on really two technologies today. The first on the treatment side is our ActiLayer technology. You can see here an installation that I'll focus on just outside of Versailles. It's a photocatalytic cover. But what's interesting is that it really performs a couple of functions in one. Well, first of all, it's a cover, so we have confinement of emissions. But here you can see a simple schematic of how it's made. So we have an activated carbon layer. So we have adsorption of any pollution below the cover. We have an integrated titanium dioxide catalyst, which with UV irradiation, so sunlight, is going to produce free radical species that will degrade any pollution that is adsorbed in the activated carbon layer. So we have complete mineralization of the pollution and regeneration of the activated carbon. So for us, it's a very interesting strategy for treatment of really difficult emission sources, open air tanks or here canals with diffuse emissions. Much lower capex than a traditional approach where if I had to put in place a concrete cover, a ventilator to extract the air, and a dedicated odor treatment system. I have no electrical power nor chemical reagents, so very easy to put in place and to maintain. And of course, the second innovation I'd like to focus on with these couple of references is the Odorprep device. Anne-Claude presented it earlier. Really what is of great interest to us is the ability to do, as Anne-Claude mentioned, remote sampling on demand by plant operators, by a system administrator in the middle of the night whenever we have an odor event. And also the fact that we can tailor the configuration of the device to have different types of sampling. So we can have cartridge sample for collecting an air sample for dilution olfactometry, or we can put in a 10x cartridge for VOC screening, for example. And just to walk through quickly two use cases. So I mentioned this is the Carré de Réunion wastewater treatment plant. It's in close proximity to the Chateau de Versailles. Here you see this is the inlet wastewater channel. So you can see it was an open air channel, approximately 200 meters in length. You'll see in some pictures that we have a new tramway passing directly in front of the plant. And in 2024, the equestrian show jumping events will be located quite closely. So the local mayors are very sensitive to this open air source and asked us to come up with solutions. Well, after comparing to different alternatives, we decided to proceed with a photocatalytic cover. Of course, we used the Odorprep as a sort of innovative performance monitoring strategy. First of all, to sample before we put the cover in place over several months to understand background odor concentrations. The Odorprep was configured with two parallel channels, again with sampling bags for conducting odor concentration in the lab via dilution olfactometry. And we could remotely sample whenever the plant operators told us that there was a nuisance event in the vicinity of the channel. We could remotely take the sample. Well, just some images of putting the cover in place. So here we put quite a sophisticated support structure because the vault was actually, well, it's a side story. It's a national monument. It's Louis XIV. So the client wanted to preserve this kind of vaulted look of the overall finish. Here you see us putting the actual cover in place. Well, just a close-up on the photocatalytic filter patch. So you have a type of chemically resistant PVC cover, and then these photocatalytic filter patches that are placed using heavy-duty Velcro at intermittent intervals integrated within the cover. We then continued with sampling with the Odorprep device once the cover was in place, and we also used microsensor technologies to sample directly in the channel below the cover and directly above the cover. It's hard to see the Odorprep in this figure, but it's just behind one of the workers here, really in very close proximity. And what you see here is prior to the project works, we really had episodes of very high odor concentrations in ambient air because we have raw sewage coming in. And you can see that post-works, again, in the immediate vicinity, it was significant reduction in odor concentration in the order of almost 90 to 95%. And then using specific measurements, both in the lab and with dedicated microsensors, we also sampled for some recalcitrant odorant compounds. And again, you see we bring it to really below detection, and we're above 80, 90% removal efficiency. And just to focus on a second reference case to give you another idea of how we used the Odorprep. What I should mention is on the first project, it was, again, a loan from Lab Services Analytica that was part of an ongoing European initiative that they had to test the Odorprep device. For us, we were absolutely convinced on the interest, and we purchased, subsequent to that first trial, 2 units for use on this next project. So here we're dealing with a different type of a project. This is an industrial remediation subsequent to an industrial warehouse fire. So here you see an image of the fire where you had a chemical warehouse that was storing highly odorant compounds. And our project within Suez and our partner consortium was to demolish the remaining structures, remediate any waste debris on site. And again, we had a lot of barrels of I guess, various states of degradation that needed to be remediated on site. So what was very important for the client is to have real-time air quality monitoring, but also nuisance odor impact monitoring as a critical decision aid tool to help manage the on-site works with as little impact on the surrounding neighborhoods as possible. Here we're directly inside the city. I don't know if you can see just behind, we have apartment complexes a couple hundred meters away. But also, this was a highly publicized, a lot of news media coverage. So we wanted to have a very transparent and reassuring communication strategy. What we put in place was a combination of multi-sensor real-time air quality monitoring stations. We put a network of 5 monitoring points around the remediation works. And we installed 2 Odorprep units for on-demand sampling, really in the direction of the prevailing winds, where we were at risk for the greatest number of complaints, where we had residents in close proximity, really on the eastern edge of the facility here, and again on the southern edge of the facility. Here you can see outlined the really the site limits, as well as in red the really focus of the remediation efforts. In this particular case, we configured each of the Odorprep units, so they were both dual channel units with sampling for dilution olfactometry, but also 10x cartridge, because we knew VOC emission screening was a big part of what our client wanted to focus on. The other critical highlight of this project is that we had to build a temporary support, a tent, for really handling the most sensitive of the waste. So again, these uncombusted barrels of compounds that were highly odorant were taken inside this tent for cleaning and pre-treatment before taking to an offsite waste handling facility. So here what we have is a combined ventilation and air treatment system where the photocatalytic filter patches are directly built in, these textile, so these are coated canvas ventilation gains with the photocatalytic filter panels integrated within one face of the ventilation gain. Again, we used the Odorprep backup, both at the very beginning of the project when we were testing to better understand what types of compounds we were dealing with and the odorant effects. We used it inside the tent as a sort of pre-screening test initially, where we were collecting samples whenever the operators informed us that we had highly odorant species present. We would collect on-demand sampling and then send it to the lab for MSGC sniffing. So the advantage is, even for compounds that were present in very low concentrations but high intensity odor, we could try and identify the compound. And then we also used the units once the project was up and running and our treatment system had been properly tested and validated. We installed the Odorpreps at the 2 points I mentioned in the limits of the remediation works to survey in real time and to do both automated sampling whenever we had a resident complaint, but also programmed sampling, because obviously we had environmental reporting to do throughout the project. So what I can show is that on the limits of the works, we never had odor concentrations that exceeded 75 odor units per meter cubed. And in the vicinity of the tent, we showed, comparing the interior of the tent versus the exterior, that we had on the order of 75 to 90% removal of both total VOC compounds and total reduced sulfur compounds. So very efficient performance.
You have a 1 minute, Robert.
And that is the last slide, Carlos. So that works
Yeah,
just
wonderful.
fine. I'll be happy to answer any questions later on during the roundtable.
Thank you very much, Robert, for sticking to your time. That's very nice from you. I forgot to mention before, we actually can, if you want if you have any questions, we will do a roundtable afterwards. So here you have our YouTube channel, and here in the chat, you can post your questions, and also if there is a link to the meeting room, the private meeting room, if you want to do your questions here as well. Okay, so our next speaker, thank you very much, Robert.
You're
welcome. Next speaker is Mr. Cesare Rossini. Please, Cesare. Dr. Cesare Rossini studied industrial chemistry at the University of Bologna, Italy. Dr. Rossini has worked in several multinational companies as a business development manager in the area of analytical chemistry applied to food safety and environment and life science. Mr. Rossini joined Lab Service Analytica in 2017 as part of the EU-funded Horizon 2020 project to promote the acquisition of Odorprep technology internationally. So please, Cesare, your go.
Thanks a lot. Thanks a lot for the kind introduction, and thanks a lot also to Claude and Robert for your presentation. That they have been a key part in the development of the project of Odorprep. Now, today, my task is to give you a presentation that was given to Lab Service Analytica by the local agency of environment in Marche. I have to explain a little bit about the company, about the public authorization who worked with the lab services. The ARPAM is the local authority, one of our 20 local authorities that are taking care in Italy of the environment. And in this specific case, the local authority of the region Marche has studied the case of Falconara Marittima, a nice little town on the Adriatic Sea in north center of Italy. The area where that we want that ARPA to keep under control has a different environmental pressure of anthropogenic origins. In this area, there are relevant infrastructure like the Adriatic Railways line, the State Road Adriatica, the civil airport, and first of all, there were important industrial activity that due to the impact with the ambient, they need regional and provincial authorization. So I am referring mainly to petrochemical plant, wastewater treatment plant. So what was the target? The target was to enrich and integrate the knowledge of air quality in the municipality with a monitoring system for pollutants related to olfactometry, nuisance, and volatile organic compounds. So what was the starting point? The starting point was that in this area of Falconara Marittima, citizen has long been concerned about the presence of odor and related discomfort. But the report was done by telephone. The telephone report were collected by the municipal administration and police, but were not treated in a systematic manner regarding the entity, the type of perceived odor, the weather condition, and the wind direction. And the other point was that the fixed position for controlling the air didn't show in the past a critical trend that was a clear message of what was going on regarding odor. Here in this slide, you can see the different sites of control that are here. 3 of them, and all these stations were producing data according to the European directive. So measurement of benzene, not methane, hydrocarbon compound, ozone, and S2O, ammonia, PM10 and PM2.5. So these were the typical way how the situation were kept under control. So ARPAM, the local authority, was invited by the municipality of Falconara Marittima to prepare a monitoring and control plan for emission related to odorous events impacting the area. This plan is based on the computerized and geo-referenced management of complaint of olfactometry harassment by citizens and allowed you to activate immediate intervention capable of answering at the following question: which area of the city is the most affected by odorous event? What are the trace substances present in the air and at what concentration? And last but not least, what is, or better, what are the sources of emission? And this plan takes into account citizens. And this is exactly an example of citizen science. Now, how was thought the system? The system was thought to have a smartphone application for the systematic and computerized management of reports. So this was the starting point. And then we have the installation of sampling system on request for timely and unintended sampling of ambient air with the remote activation when a certain number of reports reported the app was exceeded. So, in order to resume, here you have the citizen science using the population, the citizen, and here you have the measurement of what the citizens are perceiving. The first part of the monitoring system was this software, this smartphone application developed by a company called Levi-Ross that was also a partner with in the European project Odorprep. So the starting date for working was June the 22, 2019, and the period of time was about more than 1 year. And during this 1 year, the first key information was collected and clearly classified. Where are the nuisances? And this is the key message. This is the recording of all of the information collected by the population. The highest level of density is in the center of Falconara Marittima, and there is also this line, this row, all this position in row close to the airport. Worth mentioning, looking at the statistic, is that the event of odor regarding the number of reports clearly show peak period. Here, August, September, July, August, clearly in the summertime. And what is also worth mentioning here is that there was a growing interest in the population in being part of the GIS exercise. At the beginning, only 41 people took place at the exercise, at the starting, but at the end of the process, 340 people were participating. So this means that the population like to be involved in this type of surveillance and exercise. Looking at here at another information that was very clear, that there were definitely 247 days where at least 3 odor reports were reported, but you see here 65 days with at least 10 reports. And also another interesting observation is that the peak time is around 10 o'clock and around 8 o'clock p.m. The other still more information is from this surveillance program, was the 66% of the odor reported the presence of hydrocarbon-like odor. Clearly, the presence of the petrochemical plant is dominating the situation here. And also important to see is that the more than 80% of the total complaining were evaluated very strong or strong, you see from this diagram. So definitely the impact on the population was heavy. Here also we collect information regarding the direction of the wind that mainly arrive from north when you are perceiving the event. And the study of the complaining show where there is the highest concentration in this site in Falconara Centro, and also this area are where there is the highest level of. We decided to have a fixed position for measurement. 5 of them are very close to the sea, and one is more in the mainland, here close to the airport. Okay, then the starting date for the sampling started on July 2020. Each sampling station consists of a naloxone bag, 2 naloxone bag, and chemical cartridge. In addition to this, there was a PID, detect analyzer, for real-time monitoring for the total VOC compound, just to have a second information of this type. And there was also a weather station. The chemical, and then the chemical cartridge and the naloxone bag were analyzed for the identification and the quantification of the present compound. Clearly speaking, compared to the other exercise done by Claude and also by Robert, here the local authority decided to have only a chemical measurement due to the fact that they have a lab that is able to perform locally this type of analysis. So the local authority decided to, with this tool, to investigate the volatile compound, including all the different composition. And what is worth see is that during the summertime, you can see here that there were several events, 10 events. I will show only 2 of these events, and that are, fundamental for understanding what was going on. So the event of the 13, there was a huge amount of, a greater quantity of reporting close to the sea. So we activated 3 Odorprep, and here you can see all the different compound that has been measured by this instrumentation. Same event, there was another event after some days, and we activated the other 3 Odorprep, and also in this case we are done the analysis. In order to resume, because the time is running, so what are the next? The next are increasing the number of results and cases available in the time. The statistical analysis can provide us with more information on the characterization of odor events in order to also associate them to the value production process. This is the final goal. Clearly, transparency with citizens will go on, and also the connection with the local industry. So, thanks a lot for your attention. I hope that this story can be interesting for you, and I hope to have you at the during the discussion side for additional information. Thanks to everybody.
Thank you very much, Cesare. Okay, as mentioned before, questions will go after all the talks. There is the YouTube channel of olores.org. I can share you here again. Here you have the YouTube channel. If you put YouTube olores.org, you will see this channel, and there you can post your questions. And I believe link was sent to you with a direct link to this meeting room in case you want to make the question yourself. So there will be a roundtable after all the talks, and here I see that Federico is ready. So Federico Cangialosi is an environmental engineer with a PhD in environmental engineering from the Technical University of Bari in Italy. Mr. Cangellosi has been a lecturer at the TUB of Principles of Environmental Chemical Engineering for 6 years, and he is currently the Research and Development Manager of the company Tecnología e Ambiente SRL. The engineer Ken Gialossi is a member of the Italian National Standardization Body, working on the UNI, the standard Italian standard CT004 GL04 air quality since 2019, and designated member by the Italian Standardization Office UNI in CEN TC264 working group 42 air quality sensors since 2020. So Federico is going to talk to us about the mechanical biological treatment plant, statistical evaluation of hydrogen sulfide and ammonia concentrations in ambient air, and criteria for automatic odor sampling. So please, Federico, you have 15 minutes.
Okay, thank you, Carlos.
Yeah. Can you increase a little bit the sound of your microphone? You do that?
You hear me now?
Yes, now
Better?
better. Yes, now better. Yeah.
Okay. So in our presentation, we will describe a case study in which we use the Odorprep systems and other automatic monitoring devices for identification the odor complaints deriving from a nearby town. The goals of the research are the identification of the most suitable monitoring stations and chemical tracers for odor monitoring, and defining the criteria for odor automatic sampling. So far, we have seen the Odorprep activated with the human triggering. And in this case, we will see how to define criteria for activate the Odorprep with the instrument measurements. And we will use some interesting tools for continuous odor monitoring in terms of time series analysis, frequency domain analysis, and multivariate analysis. The site is a mechanical biological treatment plant authorized to receive 550 tons per day of mixed urban waste, and 3 monitoring stations were installed in 2019, located as follows. Station 3 was located upstream with reference to winds blowing towards the urban center, which is south 1 kilometer far from the plant, in front of building for West Acceptance. The station 1 and 2 are downwind, being the first one located close to the biocells and the second one close to biofilter. Each monitoring station was equipped with an H2S analyzer, an ammonia analyzer, and a VOC gas detector with the Odorprep V3. And we had also the weather station in station 3. The system was completed with data acquisition, processing, and management system. The monitoring period for this study went from September 2019 to February 2020, with about 175 days. The first look at the data we give in this presentation is the time series analysis, and we look at the data from station 3 and station 2. We remember the station 2 was close to biofilter and station 3 close to the biocells. So we can see from this data, we have here the concentration of VOC. The 98th percentile for station 3 and 2 are quite similar. And apart from this very high value in these days, we see quite low concentration, and we can see a cyclical daily component in the data. So it seems for this data that VOC is not related to the fluctuations of the emissions from the plant. In fact, if we look at the ammonia concentration in station 2 and station 3, we see the difference in terms of concentration. The 98th percentile for station 2 close to biofilter is 303 ppb against the data from station 3, which is very lower. So it seems that ammonia could be a good parameter to be related to the odor emission from the plant and in particular from the biofilter. We perform also an kind of analysis we call persistence analysis. Persistence analysis is analysis in which we search for time intervals in which a certain threshold value, y, has been exceeded consecutively for more than x minutes. All the instruments have a sampling frequency of 1 point each minute. So we decided that we can define an odor persistence if the concentration is above a certain threshold for more than 5 minutes. For the threshold values, we'll look at the different concentration. 3 values were selected for each station and each compound. 2 values were below the 98th percentiles and 1 value above that. For station 1 and 3 are the same order of magnitude, while in station 3, especially for ammonia, the value are quite higher. The persistence analysis, the philosophy be to analyze the temporal distribution of persisting events. If we have n persisting events uniformly distributed during the monitoring period, as in this picture, and we look at the cumulative events of persisting events, we have a straight line. While if in the other case, if we have n persisting events distributed during 2 specific time intervals, like in this picture, the cumulative event distribution is has 2 steps, like in this picture. So if we look at the persistence analysis of ammonia on station 3, we can see that events above 10 ppb are quite frequent throughout all the monitoring period. So we can say that we have an uniform distribution. While extreme events, in the case of station 3, close to biocells, extreme events in these cases are events higher than 70 ppb, occur in the first day of monitoring, is the red line here. When we look at the station 2 close to biofilter, events above 70 ppb are quite frequent, and we saw here the step. So the first 70 days and the last 70 days, we have frequent exceedings of this concentration, while extreme events, when concentration of ammonia is above 500 ppb, occur in the first days of monitoring. So we can say that during the first days of monitoring, high and persistence values of ammonia were recorded nearby the biofilter in station 2. Another tool, mathematical tool, which is interesting for analyzing the data acquired on a plant is the frequency domain analysis. In the frequency domain analysis, we can analyze the time series, and we can break down the values of the concentration, the time series, into the sum of appropriate periodic function, referring to all the possible cyclicities that the series can assume. As we see in this case, we have the concentration varying, which can be considered a sum of different values of different frequencies, which can be depicted in this picture, which represents the spectral analysis. So if we look at the value on station 2 and we analyze the spectra from VOC and H2S, we can see that the VOC show odor fluctuation daily. So the principal harmonic is around 24 hours and occur also on 24 hours basis, as this value is related to fluctuation in atmospheric conditions like planetary boundary layer fluctuation. So for VOC, lower frequency harmonics, which are located here in the picture, are not as evident as H2S. Near the biofilter source, H2S concentration seems to be influenced by some factor having a periodicity of days, more than hours. This is more evident for ammonia. For ammonia on station 2, we can see evident harmonics on 8 days and 5 days. So it's very likely that these fluctuations are associated with emissions that follow the cycles connected to waste acceptance in the plant and waste biostabilization, which has a duration of 14 days. So we can say that ammonia is the parameter which is close related to fluctuations on odor emissions derived from waste treatment in the plant. Another instrument we used in this case is the multivariate statistic analysis. So if we consider R the receptor, we can define a sector of upstream winds. In other terms, the wind direction that can influence the odor perceived by the receptor. And in the present case, the wind sector ranges from north-northwest to north-northeast. And if we look at the data for station 2, filtered by the wind sector, we can see that for VOC, there is a little difference when considering wind blowing from the sector north-northwest, north-northeast, and the other directions. On the other hand, for ammonia, we have higher concentration when we consider the wind sector of interest. So we can say that ammonia is the parameter which can be clearly related to the emissions from the biofilter more than VOC. And so here we make a summary of the lessons learned in this case. In this case, the plant was not equipped with an IOMS, but with multi-instrumental odor monitoring. And H2S and ammonia have common time intervals of persistence of events, unlike VOC. The spectral analysis highlighted cyclical behaviors related to the waste treatment process, most evident for ammonia, while VOC shows a cyclical trend on a daily basis for all the monitoring station. And for H2S and ammonia, the upstream, downstream differences between source and the biofilter and the monitoring station are evident by analyzing the wind directions, unlike VOC. So we can say that without IOMS, great care is required in choosing the most suitable sensors or chemical tracers to capture odor events related to the operation of the plant. So we can define the following criteria for Odorprep automatic sampling. First, we can consider that ammonia should be the only parameter to activate the automatic sampling, as its concentration is clearly related to biofilter emission, as we saw with multivariate statistical analysis. And time series shows cyclical components related to time scale characteristic of waste treatment process, as we saw with the frequency domain analysis. At time windows of 5 minutes beyond which we can find exceeding of a certain threshold, we can say that is adequate for taking into account medium and high persistence events. And so on the basis of time series analysis, we can set a threshold of 500 ppb. But in the period of analysis, we analyzed a total of 79 events of concentration higher than such value for 5 consecutive minutes. So these events during the monitoring period generated a very low number of reports from citizens. So we can say that there is little evidence that such value, 500 ppb for ammonia, may be related to nuisance to population. And so we introduced the concept of a pre-alert threshold. Each time the pre-alert threshold is exceeded for 5 minutes, it will be recorded on a web platform and an email will be sent to local EPA. And in synthesis, the criteria for Odorprep automatic sampling can be defined as follows. At pre-alert, we register event and send email to local EPA if ammonia concentration in station 2 exceeds the 500 ppb for 5 minutes, and an alert threshold, we activate our Odorprep sampling if ammonia concentration in station 2 exceeds 750 ppb for 5 minutes. This system has been operating for the last 2 months, and so far we did not receive any alert activation. So we will see with the other data in the next month. Thank you.
Thank you very much, Federico, for sticking to your time very well. Okay, so there is a minute and a half delay between this meeting room and the stream in YouTube. So I will ask to the people that is watching this webinar, please to post your questions there in the YouTube channel. But because this is going to take a minute and a half, I would like, well, first, thank to all our speakers. Thank you, Federico, and thank you, Anne-Claude. Thank you, Robert. Thank you, Cesare. Could you please turn on your camera so that we can initiate the round table, if that is possible? Yeah.
Yes, thank you.
Okay. So I see that here in this meeting room we have around 15 people. There were moments in which we had 25 people. So on the YouTube channel we will see the questions after some a while. So I have some questions that I would like to make. For example, to Anne-Claude, you mentioned that there were just only 6 events in 8 months, and so this is really, if you compare with the results that Cesare presented of 247 days in a year with 3 other reports, the difference is really huge.
Yeah.
How can you explain that? How can you explain the difference?
We were the first surprise of that very low odor events during the presence of the Odorprep sample. But however, the officer of NGIS explained us that even before the period of installing the Odorprep sample, there is a decrease in the odor complaints. So maybe we suffer of unluck. We were not very lucky. Well, it's strange to speak like that because yes, for the citizen it's much more better, of course. But so there is this strange events for the officer that they don't want. Why the other events were very low just before we installed the systems, and also they explained us that maybe the presence of the Odorprep sample could maybe have a certain impact of the process of some factories. I'm not sure about that. It's just an assumption, but that could be have a kind of yes, restriction, and so the Odorprep sample could have 2 functions at the end: static sampling, but also maybe just to show that there is a control of the odor emission in the area, and maybe that some factory can take care more of other events. I don't know. I have no more explanation than that because the weather condition were perfect for odor emission. So maybe another aspect is that the citizens were not involved at the end in the automatic activation because the official didn't want to involve the citizens to avoid to check again and to reactivate complaints because it was just more quiet, and so they don't want to reactivate the situation. So it is maybe also the reason because citizens were not involved in the study, just 2 officers. So it could be also an explanation.
Thank you. All right, this is going to be a roundtable, not me asking questions to everyone. Don't forget about that. But because we have to wait like a couple of minutes before the streaming goes, because before this goes to the streaming and we can get some questions there. I'll go to make a question to Robert, if this is okay.
Yes.
Robert, I saw in your very interesting presentation that you presented some results of odor abatement efficiency
Yes.
by using this ActiLayer cover, which is really interesting. And I wonder if you took measurements after some time. I mean,
Yeah.
not initially, but after, I don't know, a few months or a year
Yeah.
or something, to see how the efficiency, odor abatement efficiency rate varied throughout the time.
Yeah, absolutely. And this is a critical question. So the two projects I presented, the second one was obviously a short-term remediation, and the project lasted, I think, on the order of four to 5 months. So it's not relevant. But the first project at the wastewater treatment plant obviously is a permanent installation. And we have ongoing sampling. In fact, the team will be on site again within the next few weeks, take another round of measurements. So it's now been operating a little over 2 years now, and we have no significant degradation in performance. We're finding the same levels. So for the moment, we haven't had to change out the filter panels.
Mm-hmm.
It can be done quite easily because it is simply Velcroed in place. So I think at some point in time, we kind of had anticipated maybe every 2 years we would need to change out. But so far, 2 years and counting, and we're maintaining performance. Obviously, this source, it's a raw wastewater sample. It's perhaps somewhat less concentrated than if we were on an industrial. You know, we're looking at applications where we have a higher level VOC emissions, and maybe a more frequent change out will be necessary.
Mm-hmm.
But for the moment, we're quite pleased.
Mm-hmm. Very nice to have this second use of a cover. It's really a nice idea. Okay.
Yeah, I think photocatalysis, as you know, is not a new idea. It's been around for quite some time. What's interesting to us is really trying to figure out how to better apply it using modern ideas.
Actually, in the conference we are organizing, the IWA conference, I'll do some publicity here.
Yeah.
For next October, there will be a few presentations on photocatalysis and on the use of different compounds for photocatalysis, not only titanium dioxide, but other. So it's I think it's a great technique if you know the limitations, and it's really promising. There are many research papers around. So I invite you to.
Yes, thank you.
Do you have any presentation there actually?
I have to check with the team. I'm not sure, but we do regularly assist with the IWA. So
okay, so I invite you to present this
yes, thank you.
Research, because it's actually very interesting, and there will be a session with many papers on photocatalytic oxidation. Okay, I have for Cesare a very strange question. I don't see still many questions on the YouTube channel. And it's the incredible amount of complaints that they had in that area. It's I've seen many registers of complaints in the past. Some of them with many recordings, but these amounts you mentioned here, it's really a huge impact in that area.
Thanks a lot for the question, and definitely compared to what happened in Belgium, definitely there is a great difference. Just to comment here, first of all, I want to thank again team of ARPA Market for this great work and the activity they did. That definitely was amazing. But okay, this area the key source of the problem is the petrochemical plant, and also from the type of nuisance is clear, and also from the type of chemical analysis, this is clear. So the situation is quite hot, so all the population there is has a high level of motivation. Clearly, the period of time in summertime is extremely critical. And I have to admit that more than 300 people that were around the plant with a mobile phone sending message is a clear reason why you have to involve citizens. The lucky in this regard, I am sure that compared to Belgium, there was a great difference. In Belgium, there were only 2 people that were allowed to were involved. In this case, a whole citizen, 340 people were involved, and just explain the reason why you have complained. You know, more people, more complaint. It's normal. It's part of the truth. And clearly, the statistical evidence is much more important. So definitely, from this experience, I think that the Odorprep show that the capability of sampling for pure chemical analysis is fundamental. There is a lot of discussion regarding the uncertainty of the measurement when you have to use a dynamic olfactometer. It's a matter of fact. We are aware, but definitely when you measure chemical, no discussion at all. You have chemical and you know what does it mean, and also you are able to address exactly who is in that moment the source of the case. So I think that this is a clearly very good example. I know that the local authorities are going on. I know that additional event has been recorded, and also the engineer that helped me in this presentation definitely go to create basically, you know, at the end with one word, we have created with a small citizen a small city. Without a small citizen, you cannot have a small city. So this is the, you know, the last slogan that the last key takeaway for our experience.
Okay, thank you, Cesare. We are a bit late in our timing. I'm sorry. I always try to stick to time, but we are like 10 minutes late. So there are 2 things here. I don't see any question in the YouTube channel yet. But here in the platform, you can raise your hand. I don't know if you see here in the chat. So if you want to make any question, just raise your hand, connect your camera, and we will put your question here. So that this is a proactive roundtable, not just me asking questions. But if you have any, please do it here. So I have a question for Federico. I saw that you were using this IOMS or sensors in a way that connected to the environmental office, and in a way similar to we normally use remote sensing monitoring systems, that they follow a standard that is a EN 14181 with 3 quality procedures: QAL1, QAL2, and QAL3. Did the environmental agency ask you to follow this QAL labels? Because in this case, it would be really interesting, because there is some discussion about this in working group 41.
Yes, Carlos. This is a very interesting question, because for this specific case, for the mechanical biological treatment plant, the local EPA asked to use the sensors which have the requirements for ambient air monitoring. So all the sensors were from Teledyne, the H2S and NH3, and so the standards were the same of ambient air monitoring. And so this was very expensive for the plant to install such measurement systems, but that was a requirement from the local EPA. In other cases, in Puglia, we use what we call smart sensors. So they don't need to have all the qualification in terms of UL 1, 2, and 3. And we use such sensors for relating with the odor concentration like IOMS. In this case, we didn't have an IOMS. So we have ambient air monitoring instruments. And so the installation was very expensive.
Yeah. Maybe Cesar can mention one thing that we're interested in, and we've been discussing with Cesar, is their project on their net PID to integrate sensor within the Odorprep device. Then we have further advantages of a device that can do ambient air sampling and also activate sampling based on an ambient air measurement.
Yeah.
I think you're on mute.
Yes, definitely. Sorry, I was on mute. Definitely, this is our goal: is try to reinforce the sampling capability with the external device. This is a general strategy that we are under development, and we think that in the coming month we will be able to provide a complete solution on this regard.
Yeah,
Okay.
we're anxious. We're pushing you for.
Yeah, I know very well.
I see that there is a question here in the YouTube channel for Professor Romain. Here it says she presented some issues regarding Odorprep, electric supply, bugs, etc. How do you think to overcome these problems? How do you think you can do to overcome those problems?
Yeah, I don't know who is asking this question, but maybe it could be a question for Cesar and for
Actually.
Yes.
Because
Okay.
I don't know the situation now, is they are still using nanofan, or I no idea on what is the technical aspect of Odorprep now, 2 years after our first experience.
Can comment here that I think that this is my role to answer. Okay, definitely regarding the electricity. Okay, we have to admit that this is a sort of obligation that we have to have due to the fact that due to the refrigeration system we need electricity. I agree with everybody that to have something able to be autonomous should be ideal, but today we are not still able to provide this type of solution, but it's a clear need. I want also to align another problem regarding some improvement that we had compared to the version that has been used in Belgium. Now we have a complete solution in the sense that we are able to sample with the nanofan bag, with the cartridge, and with canister. So we expand and definitely consolidate the type of different way to take sample on this regard. Regarding nanofan, yes, this is a matter of fact. So there are some limitations due to the material per se. We see and we hope that with the chemical absorption we can reduce this type of negative impact. But the material is material. So sorry, this is a general issue. I should like also to outline the point that.
But you could use Teflon, for instance.
I was just going to say is that you know we don't need to get the bags supplied from LSA. I mean we use Tedlar bags all the time, so I think there's lots of different suppliers where you can provide different material.
Yes, for sure. It's just something that it is common to use nanofan and Odorprep prefer to use this, but it is important to mention that no, it's not always a good solution.
Yeah.
And just when you want to change the material bag from nanofan to Tedlar or to Teflon, just some the connectivities, and sometimes also the softness of the bags is not always the same, especially for Tedlar, and even the cartridge where we put the bag inside are quite limited in volume and in height, and so it is important maybe to adapt this to other materials. It's just this concept.
Yeah. No, that I understand. But from a user standpoint, I will say for us, it's important not to exceed 10 liters. And we count on the labs to be able to deal with 10 liters of sample maximum. Otherwise, transportation and shipping is a nightmare, just not realistic. So that's the demand we place back on the on the labs. But it is a challenge for ambient air. We agree.
Yeah.
Okay, thanks for this input. Definitely, we will discuss in the team how to solve this problem out and to identify the possible solution. Thanks for the input. I should also to add another point that now we are able to adjust the timing for capturing for sampling time. So this is something that now we have a standard feature in our solution. So clearly today the great effort is also more on the sensing side, where we are putting effort in order to develop a sensing station able to be able to cover all the different needs in terms of compounding the air. So this was the question. Nevertheless, if the colleague that just sent this request on the YouTube should like to have more detailed information, he can address directly to me via Olores any additional question and can give him more information separately. Thanks.
Yeah. Via Olores, or you have a lab service website, you can also contact them from you can send us any information, we send it over to Cesare, but if you prefer to contact them directly, that's fine as well. Okay, I have another another question here in the YouTube channel. Here it says for Cesare, Mr. Rossini, is it expected that this type of field sampling replaces something in the stack and modeling in the future?
There are some study going on. At this stage, I am not in the position to give an answer here. Something has been taken into account, but the technical feasibility is still going on. So I'm not in the position to give a date or a precise answer to this question. But also for this colleague, if he can send to me his request, I will be more than happy to keep him updated regarding what are the development on the Odorprep on this regard.
Okay. All right. We are already 20 minutes late on our time. I don't know anyone from the meeting room, if you want to connect your camera, or please, if you like, please connect your camera and make a question or any comment that you would like to do to any of the speakers. You are more than welcome to do so. But also, because I know that some of the speakers they have a limited time today. So if I don't get more questions in the YouTube channel or here. No. Okay. So thank you very much. Thank you, Robert. Thank you, Federico. Thank you, Cesare. Thank you, Claude, for your very interesting presentations. This webinar will be recorded and uploaded to the YouTube channel of olores.org, available for everyone to watch whenever they want. So it's not necessary if you missed some part of this talk. Don't worry, because it will be posted in the YouTube channel for you to watch at any time that you feel like. So thank you very much to everyone. I hope you have a wonderful day. Thanks to Lab Service, actually. Ivano, I see him now here. For this is a sponsored event by Lab Service. So thank you very much for pushing a little bit in this. Cesare did a great work. I don't know if you have to tell him and tap him in the back, but he did really a fantastic work. And I hope you all have a wonderful day, and I hope to see you soon again in another webinar, if that is possible, and of course in the next IWA conference that the olores.org is organizing in October. You are more than welcome to attend that one as well. Thank you very much.
Thanks a lot.
Have a very good day today.
Thanks, Carlos.
Thanks a lot.
Thanks, Cesare.
Bye.
Bye
Thank
now.
you.
Bye.